Now that we've uploaded the data, we define the workspaces, which are the things that you're modeling. Create up to 5 workspaces on the one dataset. The things we are interested in modeling, i.e. the response or outcome variables, are the number of gambling problems the respondent had in the past year, and secondly, the number of gambling problems the respondent had in their lifetime. Let's make the first workspace the gambling score for the last year. If you are familiar with GLMs, then for each workspace you can directly select the settings here. If you've never used GLMs before, that's okay. You can run this wizard, answer some questions, and the settings will be populated for you. So are you modeling a probability? I.e., is the response a 0, 1 or yes, no response? No. It's a score from 0 to 10. Can the response value be negative? No. It's 0, 1, 2 or 3. Are you modeling the ratio of 2 variables in your dataset? No. An example of modeling a ratio might be where one question is, how many times did you gamble last month? Which might be 8 times. And then another question is, of those, how many times did you win? Which might be 2 out of 8. Where we are interested in the ratio of gambling wins to gambling plays. In this dataset, it's not a ratio that we are interested in. Do you want your model to be multiplicative or additive? You might know for certain what you want this to be, but most of the time you won't. Most normal linear regression structures use an additive model by default, without even giving an option for a multiplicative model. The best way to think about this is that you start with a notional score, say 2, and then if some condition is true, say you didn't complete high school, then in an additive model, the score increases or adjusts by some value, like 0.5, so it becomes 2.5. Then if another condition is true, say you earn more than $40,000 per annum, the score falls by 0.7 to become 1.8, and so on, so that at the end, the final predicted score is the sum of a string of numbers that ends up being, say, 1.2. By contrast, in a multiplicative model, the effect of not finishing high school might increase the score by 10%, i.e. multiplying it by 1.1, rather than adding 0.5. You may have encountered a multiplicative model when being told to perform a log transform on the response or outcome variable. If you're not sure which one is best, you can create one additive workspace and one multiplicative workspace. Build models in both and see which one you like best. The main problem with an additive model is that it's possible for the predicted value to become negative. For example, if you start with 0.2, then subtract 0.5, then subtract 1.2, then subtract 0.4, then at that point you're down to negative 0.1, which is just not realistic when the scores can only be between 0 and 10. By contrast, in a multiplicative model, if you keep multiplying small numbers by small numbers, the predicted score will approach 0, but not ever become negative, as long as the number you're multiplying by is not negative. I'll choose a multiplicative model here for 2 reasons. Firstly, the multiplicative model is slightly more complex than an additive model, and I'd rather work through a complex example in this tutorial so that it'd be easier for you to work with an additive model by yourself later, rather than the other way around. And the other reason is because normal linear regression that traditional social science analysis uses is based on an additive model, and we want to see how Preddle can produce easier and more intuitive models than the traditional approaches by using different settings. So what is the response variable? Well, gambling problems last year. Is the response a discrete count? A discrete count is the count of events or things, so can only take the values 0, 1, 2, 3, etc. Money is not a discrete count since it can be broken down into cents. In this case, we are counting gambling problem responses, so we can answer yes to this. Are the records weighted by a variable in the dataset? Yes. They are weighted by the sample weight variable we mentioned earlier. So let's choose that. As a result of answering those questions, it's populated these drop-down boxes for us. Let's run through them so we at least have some understanding of what it did. The response variable is what you're modeling. In this case, the number of gambling problems past year. You can have Preddle apply a transformation to the response variable if you want, such as taking the square root or log or inverse. We won't be applying any transformations to this response variable. You can select a weight variable if desired, which is the sample weight variable in this case. This is what we were discussing earlier regarding the population weight. If you don't select the weight variable, then each record or each case is given equal weight. The offset variable is mainly used if we were modeling a ratio of two variables. Remember that question from the wizard? The offset variable here would be the denominator in the ratio, or the number on the bottom of the ratio. Where this was chosen, you need to pick a log offset transform. The link function and the error distribution are based mainly on questions like, are you modeling a probability, or whether you want an additive or multiplicative model. Very briefly, if you're interested, if you want to do a normal linear regression, you would choose an identity link and a normal error distribution. Identity, normal. If you are modeling counts of some event, use a log link and a Poisson distribution, like we are here. If you are modeling the size or severity of something, as long as it's positive, choose a gamma distribution. A log link makes it a multiplicative model. An identity link makes it an additive model. If you're modeling the probability of something occurring, such as whether someone will gamble or exhibit some other behavior, use a logit link with a binomial error structure. Some combinations of settings here won't make sense. For example, you wouldn't normally choose an identity link combined with a binomial error distribution. But when in doubt, just follow the wizard and accept the settings that it gives you. Let's make another workspace to predict gambling problems lifetime. We'll adopt the same settings as the first workspace, except with the different response. Let's make a third workspace. Same response as the first workspace, but this will be an additive model. So we'll call this gambling probs last year additive. Just following exactly the same answers that we answered for the other one, except this is additive instead of multiplicative. There we go.